Let us now look at the general result and its proof. If you can recollect, n bar is equal to n minus n of C1, C2, C3, C4 up to C5 is what we solved, and so on is what we solved for the 5 node graph problem. And now let us assume that there are k such conditions, C1, C2 up to Ck, and entities satisfying these conditions are put into the corresponding vowels. And look at this big rectangle. The total number of elements inside this rectangle is n in number, and what we need to count is total possible entities that are outside all these k number of Ci's, C1, C2 up to Ck, right? Okay, so the formula goes, generalizing what we discussed a while before, the formula goes something like this. N bar is equal to n minus n of C1 plus n of C2 plus n of C3 up to n of Ck, and then an alternating sign, plus n of C1 C2 plus n of C1 C3 plus n of C1 C4 and so on up to the last term n of Ck minus 1 Ck. And then again minus n of 3 terms, C1, C2, C3, C1, C2, C4 and so on. As you can see, in the previous entity, there were k choose 2 terms. Here there will be k choose 3 terms, and then k choose 4 terms, and so on. So, and the last entity will be n of C1, C2 up to Ck. Only one term, you see, because all k conditions will be put here. And the symbol in front of it depends on, see, you see minus plus is alternating. A little observation tells you it's going to be minus 1 to the power of k. It's a standard trick in mathematics. Most of you probably know it. If not, observe it deeply, you will realize why it is minus 1 to the power of k. Now, how do we show this is true? Here is a very neat trick. What I do is I will observe that every single entity inside this rectangle contributes equally to the left hand side as well as to the right hand side. This is a new form of proof. It may take some time for you to even start understanding, beginning to understand what this means. Right? So with time it will get familiar, you'll be familiarized, but then you shouldn't be surprised if you don't get it in the first attempt. Okay? So I repeat, for every single entity inside the rectangle, I'm going to show you that it contributes equally to the left hand side of this equation and the right hand side of this equation, thus ensuring that this formula indeed is true. Okay? How do I do that? Look at this. Take an element outside all these Ci's. That is counted once in n bar, obviously, because n bar is all such elements outside these vowels. It's counted once in n bar, and of course once in n, because it's indeed inside the rectangle. Correct? So once in n bar, once in n, and you see in n of C1 it is not counted because it is not inside C1. In none of these entities is it counted. Please note, a zero contribution from the first term in this n of C1 plus n of C2 up to n of Ck, it is not counted. So 0. The next one is also 0. So on and so forth, everything is 0. So 1 on the left hand side and 1 minus of 0 on the right hand side, which is 1 on the right hand side. So an entity outside a vowel, all these vowels, which is not in any of the vowels, contributes 1 on the left hand side and 1 on the right hand side. Now, what if you take an entity that is in C1? Or let's say that is an element that satisfies some random k conditions. Okay, C1, C2 up to Ck, or some C2, C7, C21, C48, so on up to some k number of, let's say R number of conditions it satisfies. Let's assume that. Then, if it satisfies R number of conditions, and if let's assume it is not outside any of these vowels, it's inside. R means R is greater than or equal to 1 is all I'm saying. Pretty straightforward. Think about it. So, which means it doesn't contribute anything to n bar. It contributes a 0 to n bar. And of course, it's within n, so it contributes 1 to n. And then to n of C1, n of C2 up to n of Ck, it satisfies R number of conditions, which means it contributes to R such Ci's. So here, those R Ci's will have a 1, 1, 1, 1, 1. The rest of it will be 0, 0. So all put together, R entities here will be 1. So 1 plus 1 plus 1 r times is r. So this term here will have this r number. Okay, it contributes, this entity which satisfies r conditions will contribute r here. Similarly, think about it. When it satisfies r conditions, given any two conditions from these r conditions, it will satisfy. So in the second term, it will satisfy r choose 2 conditions and the rest it won't. Think about it. Again, a point of confusion could be here. You may want to spend some time here and then see why it is r choose 2. Next, it will be minus r choose 3. And next it will be plus r choose 4 and so on and so on up to the point where it actually reaches r conditions. In the rth step, it will be r choose r. After that, there will be r plus 1 conditions and hence it will be 0 everywhere. Again, a point of warning. Think about how it stops at r conditions. I mean r lines here. Okay, and now it contributes 0 to the left hand side and 1 to n and then minus r choose 1 plus r choose 2 because r is r choose 1. So r choose 2 minus r choose 3 plus r choose 4 so on up to minus 1 to the r. Again, see how it is minus 1 to the r here times r choose r. So minus r choose 3. 3 is an odd number, so you put a minus. 2 is an even number, so you're putting a plus. So you observe that it will be minus 1 to the r. Now, if you stare at this, you will realize that this entity is nothing else but 0. So 0 is equal to 0. Why is this 0? It is nothing else but 1 minus 1 whole to the power of r. You see? Think. So 0 is equal to 0 and hence no matter what element you take inside the rectangle, it contributes equally to the left hand side and to the right hand side and hence the equation is true. Now look at the very weird way of proving a formula. There is yet another way of proving it and that is using induction. We leave that to you as an exercise.